Today we are going to explain or we are going to revise the unit 3. Okay, in the first unit, that is the last topic, that is direct inspection method. Okay, by using this direct inspection method, we will form the Weber's matrix. Okay, we form the Weber's matrix. Okay, first this is the given circuit diagram. Okay, this is the given circuit diagram. Okay, in that we are having the Z1, Z2, Z3, Z4, Z5, Z6 elements are there, and two voltage sources, that is E1 and E2. Okay, in the case of a direct inspection method, we apply the KCL at node 1. Okay, first we mention the nodes and then apply the KCL at node 1. Okay, what is the KCL? That is V1 minus E1 by Z1. Okay, V1 minus V1 by Z1 plus V1 minus V2 by Z3, V1 minus V2 by Z3 plus V1 minus V3. Okay, this is the node 3. V1 minus V3 by Z3. Okay, equal to the 0. Equal to the 0. Okay, then simplify this equation and then we obtain the equation number 1. Okay, then simplify this equation and then we obtain, that is the equation number 1. Okay, first apply KCL at node 1. Okay, we already well known about the KCL. First apply KCL at node 1 and then derive this equation and then we obtain the equation 1. Okay, next apply KCL at node 2. Okay, what is the node 2? Where is the node 2? This is the node 2. Okay, apply KCL in that node 2. Okay, therefore V2 minus E2 by Z2. Okay, V2 minus E2 by Z2 plus apply KCL at node 2. Okay, V2 minus V1 by Z3. Okay, V2 minus V1 by Z3. Okay, plus V2 minus V3 by Z5. Okay, plus V2 minus V3 by Z5. V2 minus V3 by Z5. Okay, this is the KCL at node 2 and then simplify this equation, then obtain I2 equation. Okay, then we obtain I2. Okay, same as that of apply KCL at node 3. Okay, apply KCL at node 3. Okay, where is that node 3? This is node 3. Okay, apply KCL at node 3. Then this is the V3. Okay, therefore V3 minus E1 by Z6. Okay, V3 minus E1 by Z6 plus V3 minus V1 by Z4 plus V3 minus V2 by Z5. Okay, then simplify this equation and then we obtain the equation number 3. Okay, by solving these three equations are from equation 1, 2, 3, that will be written in the form of a matrix. Okay, this is the in the form of a matrix. In that the diagonal elements are the y1, y3, y4, y2, y3, y5, y4, y6, y5. Okay, then the off diagonal elements are the minus y3. Okay, minus y3, minus y4, minus y5, minus y5 and y5. Okay, this is plus y5. Okay, plus y5 and this is minus y5. Okay, this is the diagonal elements and these are the off diagonal elements. Okay, then we write down the y11. Okay, then we write down the y11. This is the y11. Okay, this is y11. Next, this is y12. Next, this is y13 and this is y21. Okay, y21. Okay, Okay, after that this is y 2 2. Okay, these are the diagonal elements y 2 2, and this is y 2 3. Okay, y 2 3. Next, this is y 3 1. This is y 3 2, and this is y 3 3. Okay, this is the Y bus matrix by using the direct inspection method. Okay, this is the Y bus matrix by using the direct inspection method. Okay, coming to the problem for this direct inspection method, that is first this is the given problem that will be related to the direct inspection method and then form the Y bus matrix. Okay, for the same network, write down the loop equation and hence determine the elements of a Z bus matrix by direct inspection method. Okay, this is the loop. Determine the elements of a Z bus matrix by direct inspection method. Okay, therefore y is equal to the 1 by Z and Z is equal to the 1 by Y. Z is equal to the 1 by Y. Okay, then this is the given circuit diagram. By using this circuit diagram, we form the Y Z bus matrix by using the direct inspection method. Okay, the diagram is redrawn in this model. The diagram is redrawn this model. Then mention the nodes. Okay, this is the node 1, node 2, node 3, node 4. Okay, we are having the 4 nodes. First apply KCL at node 1. Okay, apply KCL at node 1. Okay, V1 minus E1 by J 0.1. Okay, V1 minus E1 by J 0.1. E1 is the 20 at an angle of minus 60 degrees. Plus V1 minus V2 by J 0.1 plus V1 minus V4. Okay, this is the V4. V1 minus V4 by J 0.05. Okay, this is the KCL at node 1. Okay, this is the KCL at node 1. Okay, then simplify this equation and then that mention that is the equation number 1. Okay, same as that of apply KCL at node 2. Okay, apply KCL at node 2. What is that KCL apply at node 2? That is V2 minus V1 by 0.1. Okay, next V2 minus E1 by J 0.2. Okay, next V2 minus V3 by J 0.2. Okay, V2 minus V3 by J 0.2 plus V2 by J 0.2 plus V2 minus V1 by J 0.1. Okay, then simplify this equation and then mention that is equation number 2. Okay, same as that of apply KCL at node 3 and also node 4. From equation number 1, 2, 3, 4 and then from equation number 1, 2, 3, 4 we form the Y bus matrix. Okay, we form the Y bus matrix. Okay, next coming to the second problem, form the admittance matrix by using the single line diagram. Okay, this is the single line diagram. By using this single line diagram, we form the Y bus matrix by direct inspection method. Okay, what is the formulas for the direct inspection method? That is first one is the Y11. Okay, this is the 1. Okay, Y11 equal to the 1 plus J2 plus 3 plus J3. Okay, 1 plus J2 plus 3 plus J3. Next Y22. Okay, where is that 2? That is Y22. Y22 is equal to the 2 plus J1. Okay, 2 plus J1 plus 3 plus J3. Okay, 2 plus J1 plus 3 plus J3. Next Y33. Okay, Y33. 2 plus J1 plus 1 plus j2. Okay, 2 plus j1 plus 1 plus j2. Okay, this is the diagonal elements y11, y22, y33. Okay, diagonal elements. Okay, after that we find out the non-diagonal elements, that is y1, that is y12, y13 and okay and y23. Okay, y12. Okay, we are having any connection between 1 to 2? Yes, that is 3 plus j3. Okay, then we mention minus of 3 plus j3. Okay, then we mention minus of j3 plus j3. Okay, why we are using that minus? From the admittance matrix, by single line diagram, the direct inspection method. Okay, form the admittance matrix. Admittance matrix form cheminappudu y12 equal to y21 equal to minus of that element. Okay, 1 to 2. 1 to 2 is the 3 plus j3. Next y13. Okay, this is 1 3. Okay, 1 3, we are having the element that is 1 plus j2, 1 3. Okay, 1 3 is also there, that is 1 plus j2. 1 2 3 is the minus of 1 plus j2. Okay, 1 plus j2. Next y2 3. Okay, there is a connection between 2 to 3. Okay, this is the connection between 2 to 3. That is 2 plus j1. Okay, that is 2 plus j1. Okay, this is the formation of the admittance matrix or the Y-bus matrix by using the direct inspection method. Okay, what is the formulas for that direct inspection method? Y11 equal to the 1 నుంచి ఏవైతే కనెక్ట్ అయి ఉన్నాయో వాటిని యాడ్ చేసుకుంటాం. ఓకే, y11. ఓకే, 1 2 3 ఉంది, అలాగే 1 2 2 కూడా ఉంది. 1 plus j2 plus j3 plus j3. Okay, next y22. Okay, what are that is connected? That is 2 plus j3, 3 plus j3. Okay, which elements are connected? 2 plus j1 and 3 plus j3. Okay, next y33. Okay, which elements are connected? That is 3 1 and also 3 2. That is 1 plus j2 plus 2 plus j3. Next y12. Okay, there is any connection between 1 to 2, then we represent that is minus of that connection, minus of that element. Next y13. Okay, there is any connection between 1 to 3, that is minus of 1 2 3, that is minus of 1 plus j2. Okay, minus of 1 plus j2. Next 2 to 3 or 3 to 2. Okay, there is a connection between 2 to 3 or the 3 to 2, that is minus of 2 plus j3. Okay, this is the formation of the Y-bus matrix by using the direct inspection method. Okay, this is the Y-bus matrix. This is the Y-bus matrix. Okay, this is the complete first unit. In that we are having the only 3 topics. That is, first one is the per unit impedance values or the reactance diagram. Next one is the singular transformation or the formation of the Y-bus. That is A instance matrix, bus instance matrix, loop instance matrix, basic cut set matrix. Okay, by using this we form the Y-bus matrix. Okay, next last one is the direct inspection method. Okay, by using the direct inspection method we derive or we form the Y-bus matrix. Okay, these are the 3 methods that will be related to the first unit. Okay, next coming to the third unit, that is formation of the jet bus. That is formation of the jet bus. Okay, in that formation of the jet bus, the main topic is the we are having the 4 types. Okay, main topics is the 4 types of methods are there. We are having 4 types of methods are there. That is the type 1, type 2, type 3, type 4 methods. Okay, in that type 1 method, okay, type 1, type 2, type 3, type 4 methods. Type 1 method, that is the addition of a element from a new bus to the reference. Okay, adding a branch, this is the adding a branch from new bus to the reference. Okay, from new bus to the reference, that is the type 1 modification. That is the type 1 modification. Okay, in that type 1 modification method, we form the Z bus new. Okay, therefore Z bus new is equal to the Z bus old. In that 0 and 0 row is added and 0 column is added. In the last for that Z bus matrix, we are having the ZBR, that is the ZB. That is the Z branch or the addition of the element. Okay, this is the addition of the element. This is the formation of the Z bus. ఓకే, ఇక్కడ అంతా మనం జీరోతో రిప్రజెంట్ చేస్తే ఇక్కడ మాత్రమే జెడ్పీతో రిప్రజెంట్ చేసుకుంటున్నాం. ఓకే, దిస్ ఇస్ ద టైప్ 1 modification. Next, coming to the type 2 modification, that is the addition of branch that from the ZB to the connection of a branch between the connection of a branch ZB in the existing bus J, okay, with the old bus. Okay, that is the type 2 modification. That is the type 2 modification. Okay, in that type 2 modification, therefore the Z bus new is equal to the Z bus old and Z1J, Z2J and so on ZNJ. Okay, and also ZJ1, ZJ2 and so on ZJN. Okay, after that ZJJ plus ZB. Okay, after that ZJJ plus ZB. Okay, ZB is the adding element. ZB is the added element. Okay, ZB is the added element. Okay, therefore Z bus new is equal to the Z bus old, Z1J, Z2J and so on ZNJ, and ZJ1, ZJ2 and so on ZJN. Okay, in that ZJJ plus ZB. Okay, in that ZJJ plus ZB. Okay, this is the type 2 modification. Okay, next, coming to the type 3 modification. Okay, type 3 modification, this is the type 3 modification. This can be considered as an extension of a type 2 modification. Okay, this is the extension of a type 2 modification. Okay, in that, assume ZB be connected a new bus P. Okay, ZB is connected to the new bus P and an old bus J. Okay, where J is the old bus. Okay, then let the new bus P be connected to the reference bus. The new bus P is connected to the reference bus. Okay, then we obtain the Z bus matrix. Okay, then we obtain the Z bus matrix. Okay, this is the Z bus old bus matrix. This is the Z bus old bus matrix. Okay, in that we may represent the Z1J, Z2J and so on ZNJ. Okay, this is the ZJ1, ZJ2 and so on ZJN. Okay, into ZBB plus ZBR, that is the branch, that is the added element. ZBR is the added element. Okay, ZBB plus ZBR, ZBB plus ZBR. Okay, this is the type 3 modification from addition of element from a new bus to the reference bus. Okay, new bus to the reference bus. Okay, this is the type 3 modification. Okay, new bus to the reference bus. Next, coming to the type 4 modification. Okay, this is the addition of a branch ZB between the old bus I and the J. Okay, therefore the new bus is a branch is added in between the old bus to the new bus. Okay, the branch is added in between the old bus to the new bus. Okay, that is the type 4 modification. Okay, that is the type 4 modification. Okay, in that the type 4 modification, V1 is equal to the Z11 I1 plus Z12 I2 plus and so on Z1 I into I1 plus IP plus Z11 into I1 minus IP plus and so on Z1 and IN. Okay, then we obtain VI, Vj, and by solving this equation, we form the that is in the matrix form, that is V1, V2, and so on Vi, Vj, and so on Vi. Okay, therefore that is equal to the Z bus whole and Z1I minus Z1j, Z2I minus Z2j. Okay, Z2I, II minus Zij, Zji minus Zjj and so on, Znj, Zjj, then I1, I2 and so on, II, Ij, Ix. Okay, after that, we find out that is the Z bus mu. Okay, therefore, we find the Z bus mu is equal to the Z bus old minus Z bus old minus 1 by ZBB, Z bus old minus 1 by ZBB into Z1I minus Z1J into Z2I minus Z2J and so on Zni minus Znj into Zi1 minus Zjy in my and so on Zin minus Zjn. Okay, this is the type 4 modification. Okay, in this case, our formation of the fibers, we definitely follow these types. Okay, we by observing the one problem and then by adding the one by one branch or the by adding the one by one branch to the network, then we observe the which type of the system is there. After that, we form the Y-bus matrix. Okay, by observing that problem, which type of this, which type of the which type is there, that is type 1, type 2, type 3 or type 4. Okay, and then we add the branch from the previous network. Okay, and then only we add the branch for the previous network. Okay, this is the type 1 modification, type 2 modification, type 3 and also type 4 modifications. Okay, by using this modification, we derive the overall Z bus matrix. Okay, by using these modifications, okay, we derive the Z bus matrix. Okay, coming to the problem that will be related to the formation of the Y bus matrix. Okay, coming to the problem that will be related or the formation of the Y bus matrix. Okay, by observing these four types, we derive the Z bus matrix. Okay, by using this only, we calculate or we solve the problem that will be related to the Z bus matrix. Okay, first we are having the first we draw the diagram for the given circuit or a table, and then we observe the different steps. Okay, and then we observe the different steps. Okay, and observe the some example problem. Okay, this is the given network. Okay, this is the given network. Okay, this is the first node and this is the second node and this is the third node and this is the fourth node and this is the fifth node. Okay, we are having the 5 nodes in the given single line diagram, and then we mention the elements. Okay, we are mention the elements. Okay, this is the element 1, and this is the element 2. Okay, and this is the element 3, and this is the element 4, and this is the element 5. Okay, this is the given problem. By using this single line diagram, we build the Z-bus matrix. Okay, we build the Z-bus matrix by using this single line diagram. Okay, we build the Z-bus matrix. Okay, therefore Z-bus matrix. Okay, before going to form the Z-bus matrix, we observe which type of element is added. First, we add the element 1. Okay, where is that element? That will be there in between the nodes 1 and the 2. Okay, coming to the step 1, this is the element 1 and this is the nodes 1 and 2. Okay, this is the which type of modification is there? This is the type 1 or type 2. Okay, this is the element 1 is added to the bus and create a new bus 2. Okay, old bus to add a old bus to add a new bus to the new bus. Okay, so the element is added or a branch and there is a no mutual coupling. That is the type 1 modification. Okay, this is the type 1 modification. Therefore, the bus 1 is the reference bus. Okay, the element is added between the reference bus to the new bus. Okay, the element is added in between the reference bus to the new bus. Okay, an addition of branch ZB from a new bus to the reference bus. Okay, it is a type 1 modification. Okay, the element is added in between the reference node to the new bus. Okay, 1 is the reference node and 2 is the new node. Okay, then it is a type 1 modification. Okay, in that type 1 modification, what is that formula? Therefore, Z bus is equal to the, what is that formula? That is Z bus is equal to the, okay, what is that reference node? 1, 1. Okay, which node you will adding? That is 2, 2. Okay, 2, 2. Okay, this is the Z bus matrix after adding the element 1. Okay, first, what is the old bus? That is 0. Previous command came old bus ledu. Okay, that is the 0. And then we mention these are all the zeros. Why? Because we are mentioned this, the 2 are also 0 means that it is a type 1 modification. Okay, this is the ZBR. Okay, this is the ZBR. Okay, ZBR means the element 1 value. Okay, the element 1 value. The element 1 is added in between 1 and 2. Okay, therefore ZBR is equal to the value of this element 1. Okay, this is the Z-bus formation for the step 1. Okay, next coming to the step 2. Next coming to the step 2. Okay, what is that step 2? Next form the Z-bus matrix. Okay, that is, therefore, the element 2 is added. The element 2 is added in between first node. Okay, this is the second node and this is the third node. Okay, this is the element 1 and this is the element 2. Okay, the element 2 is added in between the nodes 2 and the 3. Okay, what is the 2 node? That is the old bus. Okay, that is the old bus. The element 2 is added. That is, element 2 is the old bus. Okay, what is the element 3? That is the new bus. Okay, therefore, old bus to the new bus. Okay, therefore, the element is added between the old bus to the new bus, old bus to the new bus. Okay, therefore it is a type 2 modification. Okay, the if the element is added in between old bus to the new bus, it is a type 2 modification. Okay, and then we find the z bus. Okay, this it is the type 2 modification. Then we find out the z bus matrix. Okay, therefore z bus is equal to the, therefore z bus is equal to the, what is the type 2 modification? Z bus is equal to the z bus old. Okay, that is remove the reference bus, that is 2 3, only we mention 2 and the 3, remove the reference, that is 1 remove 2 3. Okay, what is that value? 2 2. Okay, this is the 2 2 ZBR. Suppose the element 1 value is the 0.5. Okay, the element 1 value is the 0.5. Z22 is equal to the 0.5. Z22 is equal to the 0.5. Next Z23. Z23. ఓకే, ఇక్కడ ఏదైతే మనం రాసామో సేమ్ వాల్యూని ఇక్కడ కూడా రాస్తాము. ఓకే, వాట్ ఈస్ ద టైప్ 2 మోడిఫికేషన్ లో ఇక్కడ ఏదైతే మనం రాసామో సేమ్ ఇటు ఇటు కూడా అవే రాస్తాం. ఓకే, దట్ ఈస్ ద టైప్ 2 మోడిఫికేషన్. ఓకే, ఇక్కడ వచ్చేసరికి మనం ఏం రాస్తాము అంటే ఇక్కడ ఏదైతే మనం ఉందో ఆ వాల్యూ ప్లస్ ZBR, దట్ మీన్స్ ద ఎలిమెంట్ 2 వాల్యూ. Okay, plus ZBR, that is the element 2 value. ఏదైతే ఎలిమెంట్ యాడ్ చేసామో అది ZBR 2 value suppose 1 అనుకుందాం, అప్పుడు 0.5 plus 1, that is 1.5. Okay, this is the step 2. Next we add the element 3, element 4, element 5. Okay, after adding the elements we observe the which type of modification is there, and then we write down the type name. After that we form the Z bus matrix by using these following steps. Okay, that is the formation of the Y bus or the formation of a Z bus building algorithm. Okay, that is the formation of a Y bus or the formation of a Z bus building algorithm. Okay, we already derived the, or we have solved so many problems. Okay, this is the different problems that will be related to the formation of a Z bus. Okay, that is the derivation for that ZBI, ZBR and also ZBB. These are the different problems that will be derived by the formation of a Z bus. Okay, this is the addition of the elements. Okay, step 1, step 2, step 3, step 4. Okay, this is the given problem and different steps are there. Okay, this is another problem. In that case, we are giving the table. By using this table, we draw the single line diagram. Okay, after that we add the step by step of elements. Okay, and then we observe which type of modification is there, and then write down the type 1 modification or type 2 modification. Okay, this is the formation of a Z bus matrix. Okay, this is the type 1 modification, and this is the type 2 modification, and this is the type 3 modification, and this is the type 4 modification. Okay, this is the some example problem. First, step 1, taking the 0 as a reference. Next, step 2, adding the element 1 between the reference bus to the new bus. Okay, this is the 0 is the reference bus, 1 is the new bus. Okay, therefore Z bus is equal to 1. Paina 0 0 untai. Okay, next adding the element between the 1 to 2. 1 is the old bus and 2 is the new bus. Okay, old to new bus is the type 2 modification. Type 2 వచ్చేసరికి ఇక్కడ ఏదైతే ఉందో Z2 టు అదే వేసుకుంటాం ఇక్కడ. ఓకే, 0 అనేది రెఫరెన్స్, 0 అనేది మనం అసలు తీసుకోము. 0 తీసుకోకుండా 1 నుంచి మనం కన్స్ట్రక్ట్ చేసుకున్నాం. అంటే ఏంటి, ఇక్కడ మనం ఏం కన్స్ట్రక్ట్ చేసుకున్నాం, 1 2. ఓకే, ఇక్కడ 1, ఇక్కడ 1, ఇక్కడ 2 తీసుకుంటున్నాం. ఇక్కడేమో ఇదేమో 1, ఇక్కడ కూడా 1, ఇదేమో 2. కాస్త రావట్లేదు, ఇది కూడా 2. ఓకే, ఇలా 1 2 తీసుకొని మనం కన్స్ట్రక్ట్ చేసుకున్నాం. ఇక్కడ ఏంటి, ఇక్కడ ఏదైతే ఉందో జెడ్ బస్ అదే రాసుకుంటాము. ఇటు సైడ్ కూడా సేమ్ ఇక్కడ ఏ వాల్యూ అయితే ఉందో అదే తీసుకుంటాము. ఇక్కడ వచ్చేసరికి ఇది ప్లస్ మనం యాడ్ చేసే ఎలిమెంట్. ఓకే, ఈ ఎలిమెంట్ ఎంత, 1 + 1. ఓకే, therefore 2. Second element is the 2. 1 + 2, that is equal to 3. That is equal to the 3. Okay, same we add the element 3. Okay, that is the type 3 modification. Okay, in that type 3 modification, that is we are having the formula is there, type 3. In that type 3 modification, this is the type 4 modification formula. Z bus new is equal to Z bus old minus 1 by ZJJ plus ZKK plus ZBR minus 2ZBK. Okay, that is the type 4 modification formula. Okay, we are having the type 3 modification formula is there. Okay, this is also type 4 modification. This is the type 3 modification. Therefore, Z bus new is equal to the Z bus old minus 1 by ZKK plus ZBR into Z1K, Z2K, ZKK and so on ZNK into Z1K, Z2K and so on ZKK and ZNK. Okay, this is the formula for that type 3 modification, and in the previous we already discussed the type 4 modification formula. Okay, this is the type 4 modification formula. Okay, this is the type 4 modification formula. Therefore, Z bus new is equal to the Z bus old minus 1 by ZJJ plus ZKK, ZBR to ZJK. Okay, this is the type 4 modification formula. ఓకే, ఈ ఫార్ములాస్ గుర్తు పెట్టుకుంటే మనం ఈజీగా ఏ ప్రాబ్లమ్ అయినా సాల్వ్ చేయొచ్చు అమ్మ. ప్రీవియస్ పేపర్లో మనకి కొన్ని ప్రాబ్లమ్స్ ఉన్నాయి, అవి తీసుకొని మీరు డిరైవ్ చేయండి. ఓకే, డిరైవ్ చేస్తే అది ఏ టైప్ ఆఫ్ మోడల్, ఏ బ్రాంచ్ యాడ్ చేస్తున్నాము, న్యూ బస్ నుంచి రెఫరెన్స్గా లేదా రెఫరెన్స్ టు న్యూ బస్సా లేదా న్యూ బస్ టు ఓల్డ్ బస్సా, అవన్నీ కూడా మనం అబ్జర్వ్ చేసుకుంటూ ఫార్ములాని మనం డిరైవ్ చేసుకోవచ్చు. ఓకే, దిస్ ఇస్ ద one type of method in the third unit, that is the Z bus building algorithm. Very very important problem, compulsory in each set we are having the single problem. Okay, definitely 15 marks కి ప్రాబ్లం అనేది కంపల్సరీగా మనకి పేపర్ లో ఉంటదమ్మా. కాబట్టి కంపల్సరీ మీరు ఓన్లీ 4 స్టెప్స్ ని నేర్చుకొని ఆ ఏ ఎలిమెంట్స్ ని మీరు
ఇందాక నుంచి అది రావట్లేదు మేడం, స్క్రీన్
షేర్ రావట్లేదా?
అవును మేడం.